Hey guys, welcome back to Classic Arcade Repairs. This is Sean with you, and I have my second Warlords PCB in the last 2 weeks. Yeah, my last one was a little while ago. It wasn't too long ago. This is a pretty nice board. We got one RAM replaced right here. And I think these sockets have been replaced up here. As you can see, those are not the typical Atari style sockets. So I think they've been replaced. All the other sockets look old school Atari. But they look like they've been flowed. A lot of stuff has been reflowed on here. Not replaced, just reflowed. So that's okay. This is the this is the RAM right here that has been replaced. That one right there. And I hope that you can see it. I cannot see it on this camera because I do not have my glasses on. I just can't see that. So I mean, I can vaguely see it. It kind of looks okay. I'm not sure. I'll get a better look at it at a different time. But yeah, these ones up here, they've been replaced, remember. Take a preliminary look. That looks like a little flakage right there. That could be shorted. I can't tell. But it looks like that might be jumping a short right there. Maybe? Possibly. Something to keep in mind, that's for sure. And then you got this over here that looks okay. That's just suspect right there. That stuff. So I'll have to keep that in mind. And there's a lot of flakage going on. A lot of little solder flakes. It needs to be cleaned up. All in all, not a bad looking board. So I think that we're ready to just go ahead and get my Warlords harness adapter out and hook this baby up and see what happens. Okay, we got our Warlords harness out and we're hooked up, ready to monitor some power. We're going in color. I got the the cocktail wire grounded. Or yeah, that's right. Cocktail wire has to be grounded because the color version is the cocktail version. I always forget that or get mixed up anyway. So let's go ahead and fire on. Boy, that don't sound good. We're looking at 5.10 volts. I'm going to crank that down slightly. Let me get under here and find that pot and kind of go down with it. Wrong way. And we're right there. Let's keep it right there. So we got an annoying noise. And if we come over here, bad ROM, bad RAM. That's not very promising, is it? Bad ROM, bad RAM. Okay. I'm going to grab my logic probe and I'm going to start probing on these. Even though it might not be nothing to do with the RAM or the ROM. It could be totally decoding. It could be something. Nope, that was absolutely a bad socket. I'm gonna have to, let me reseat these. I'll be right back. Okay, so I have replaced, or not replaced, I've reseated all of these guys. I have not reseated this. I could play around with that for a little bit. Maybe give it a little. Yeah, that ain't doing anything. Yeah, this stuff, it's just not doing anything. So I think first things first is maintenance is in order. So I'm going to replace these sockets. So let's do that, and then we'll get back. I've checked the other voltages. The neg 5 is great. The plus 12 is great, and you see that 5 volts is. It doesn't get much better than that. So let's go ahead and replace some sockets. Get some good connections going. All right, be right back. Alright guys, I have said before that these types of EPROMs and these Atari sockets, like these guys, the only way at this age that I trust these sockets is if they are used with the type of ROMs that use the silver plated legs, like Galaga custom chips, where they tarnish really black. Well, you can use Tarnex and remove all of that, and they are, you know, they are absolutely clean silver legs. And then you can use Tarnex on these little gold contacts. Just brush some Tarnex on there and then wash it off, and that will make a solid like new contact. That's the only time I reuse these. These ROMs right here, you can tell these legs have been cleaned. Somebody like sanded them or something, and they are now microscopically not flat, not a flat contact surface. And that's a problem, because these are little contact points. They're not a swipe. They are two contact points like this. And if you have microscopic, just little scratches, see all them scratches on there? Those create divots in that leg. And that's enough for these to not contact these sockets. That is why I always replace these. But there have been a couple of cases where Missile Command is one that I've seen it on quite a bit, or a few times anyway. Missile Command boards will sometimes have the ROMs that have the silver legs, and you can clean those and reuse these, and they're great, no problem. But with ROMs like this with bad legs, forget it. You're not going to get good contact on that. So you really don't have a choice. If you want this thing to be solid, you want it to be turn it on and forget about it solid, these have to go. That's all there is to it. So that is what I'm going to do. I just wanted to point that out. That's a perfect example of what I always talk about, why I replace these things. So I'll be back. Okay guys, and I have gone and I've got all of the sockets removed. These were all reflowed with a heavy flux solder at some point. See how these are reflowed. Whoever did it used a really heavy flux solder. So I'm going to clean all of this off. Remove all of this flux off the board so that I can better see what's going on. So that is what I'm going to do. And then we will be ready to repopulate. All the sockets came out nice and Nice and good. Nothing broke. So, alright. Shall return. Okay, everybody. We have our ROM socket work done. I'm just taking a quick peek. Make sure all the legs are in the sockets, and it looks like they are. So we got our ROMs back in, new sockets. Looking good. So we're ready to go ahead and fire the thing up. I got it hooked back up. So let's see what we get. Oh, we got noise up on the speaker. It's not looking good. Bad RAM, bad ROM. So we definitely have logic issues because our connections are all good now. So we've got some logic problems on this guy. Test do anything. It is in test. It doesn't do anything when I put it out of test. Just a dark screen. Okay. So you put it in test, it goes bad RAM, bad ROM. Okay. Well, it's able to perform that test. So maybe the buffering is good because it can actually perform the test, and it says bad RAM, bad ROM. So I'm kind of thinking that this might be a job for the fluke. I could put the fluke on it and verify these ROMs and the RAMs. So let's do that. That's going to be next step. Okay, we are ready for some fluke action. I've got it all hooked up, everything's turned on, and we're just going to jump right into it. I'm going to do ROMs first. CPU, ROM. We'll go 5000 to 57FF, right? Yeah. 6C0B. 6C0B. Start again. Sometimes it does. I don't get this, but it does this. 6C0B. Now we're rolling. Okay. It tells me my address buffering is good and my ROM data buffer is good. So that's cool. Now we'll go to 58 to 5FFF A68E A68E. This is 153 ROM. And it's okay. Now we're going to test 158 ROM, which is 6000 to 67FF, which is 6FAC. 6FAC. Okay, now we'll go to 68 to 6FFF, and we got, what is that, F793. F793. So far so good. On to 7000. And that is B, E25. B, E25. Okay, and last one. ROM at 78 to 7FFF 559. Okay, all the ROMs come back good. And my self-test was saying that the ROMs were no good. One of the ROMs was bad or something. So that's not very promising. Let's move on to some other memory stuff. Program RAM 0. RAM short 0 to 3FF. Bits 0F. We got one bad RAM. That's going to be... There's two 2114s on the board and one of them's bad. So we just have to look at which one is the lower 4 bits. So that's easy. That'll be no problem. Let's continue on. Playfield RAM is 4000 to 7BF. RAM 700, right? Yeah. 700. Nope, 400 to 7BF. Hey, all right, that's good. Now we got object code, it says, is 7C0 to 7CF. It's a short little guy. And that's okay. Vertical position 7D0. Boy, this could have just been like 4000 to 4000 to 7FF, or 400 to 7FF. So let's just go 400 to 7FF. That kind of covers all of it. And the screen looks good. It's doing what it needs to do. Okay, that's all of the RAM. Custom audio chip. 1000 to I'm going to do right at 1000. Let's go 55. I'm just playing around now. Let's do a walk at 1000. Data toggle at 1000. Loop. Stop. Okay. Okay. I was just messing around. Okay, it looks like we only got just one bad RAM. So I need to look at the schematic and find out which of the program RAMs is the lower 4 bits. And I think this thing might work right after that. So, it's possible. Okay. Well, let's take a look at the schematic. We'll be back. Okay, and in looking at the schematic, you see that the lower 4 bits are connected to this guy. I think that's P1. Data bits 0 through 3. the lower 4. P1. So that's going to be your bad chip. So let's go take a look at that. Okay, and here we have these 2 RAMs. And this one right here you'll see is P1. You have N1 and P1. So this is going to be our bad guy right there. So let's go ahead and get that out of the board and put a new one in there. Socket it, of course. RAM, memory, sockets. And go from there. Okay, so we got this guy replaced. This is the old one. We have a new one in the board. Socketed nicely. So we'll go ahead and switch on. And board is on. And look at that. It's looking good. We got some play testing to do. Hook up our player 1, 2, 3, and 4 pots and test all of the buttons and all of that good stuff. Sound, test the sound. So we'll set the camera up and do all of that. Okay, so we are ready to start doing some testing. Some good old testing. No, we're not. We don't have the pots plugged in. That'll just take me a second. Plug these pots in. Okay, pots are plugged in. Alright. Untangle the pots. Coin. Oh, I don't need to put in a coin. Let's press all player starts. Alright, we're all in. Here's this guy. One of them's not in. One of them didn't get in. One of the button pushes didn't take, and that's messed up. See that? Look at that. Something definitely is weird. Yeah, look at that. They're turning into plus symbols. Oh, and the fireball is red too. Sound is good. Alright, I kind of think that we have a ROM problem. I'm going to put it into test. And our pots are good. They work good. And this one. Yep, all 4 pots are good. Let's do button test. Button test is good. All right. So we have a problem. Let's watch that fireball. See that fireball turns red? It's like it's... Boy, that's weird. And these guys, when they were going around, would turn into plus symbols. Very strange. Strange indeed. I'm kind of, my first thought is one of these guys. That's my first thought. But you never know. So we'll have to take a look for sure. Okay, yeah, I don't know what these do up here. Nothing, I don't think. All right, let's take a look at all of that. Let's take a look and see what we can find out about the weirdness going on. All right, I'll be back. Okay, I've just kind of been looking at the screen here, and what it seems to me is going on is, if you watch the fireball obviously is a sprite, right? Watch it. See how it turns color? It goes red right through there. See how it's turning red? It goes through. To me, it's like the sprites and the background picture, like tiling. The sprites should take precedence over that, and it looks like it's not. That's what it looks like is happening to me. So is that a muxing issue? Is that a... I'm not exactly sure, but we're about to find out. We're gonna go hunting for bad signals. We're gonna go hunting for funkiness. There's something funky is definitely going on here. But it looks to me like a priority issue. Sprites should take priority, and it doesn't look like they are. That's kind of what I'm thinking. So with that being said, I made myself a schematic, printed it off. It's still a little fuzzy and not exactly easy to read, but our RAM is good, we know that. Our playfield address selector, I'm sure, is just fine. I think where things are getting mucked up is from here on out. This is the actual motion object circuitry, which I think is fine because the motion objects are exactly where they need to be. So let's disregard this. Let's concentrate from here over. Then this goes to the video outputs. I think it's right in here. So I'm going to start right here and work my way this way. That is my plan of attack. So, okay. Let's start with this guy right here, which is a... I don't even know what that is. What is that thing? LS153 at... Does that thing even have any outputs go out of it? What is that doing? I don't see it. There's nothing on the outputs. Okay, what the heck is going on here? What's going on? That makes no sense. The outputs aren't connected to anything. I have to ask my cat about that one, see what she says. I wonder if there's come on, there's got to be something on the outputs. That might be something where I have to trace it out and complete the schematic, for crying out loud. Because that has to do something, right? Oh, goodness gracious. Well, you got all of these muxed bits here. These are 153s. So we're going to look at all of this stuff. When 256H is low and 4H is high, AB4 and AB5 from the MPU address bus is the selected output from M4. The selected output. The output is applied to the multiplexers H4, J4, K4, L4 as select inputs. When the MPU is accessing the playfield code multiplexer, the playfield data is either being read or updated by the MPU. When 256H is high and 4H is low, the inputs from the sync generator are the selected outputs. Okay, playfield code is eventually displayed on the monitor. Okay. Okay, yeah, okay. Data Prom. Ooh. Okay. Okie dokie. Good stuff. Yep, okay. Alright, like I said, this guy right here, I'm going to try to figure out what's going on with this guy right here. Let me do a little bit of research and stuff on this. I got to blow this up on my computer screen and check this out. So I will be back. I might look for another schematic too. I might dig the internet for a clearer schematic. I'll be back. These are the two Prom chips in the board. Here and here. I just removed them. They are video Proms. And they are about to fall apart. So I don't know if they're any good or not, but I'm going to have to replace them because the legs are like doing this. So they're not long for this world, so I'm going to replace those two guys. And one of them is the color Prom itself, so that might be bad. That might be the problem. Who knows? But anyway, they're not good. They're flimsy, so I'm going to replace them. Let me do that. Alright guys, I did find some better schematics. And what I did to find the fault on this was I kind of went back to, it's just a weird, it was a weird color issue, right? Where the ball would go around, or the fireball would travel around and then it would mask some color. So all the video was good. You know, the video data and everything, and going out to the picture of where everything is good. It's purely a color issue. So with that being, I rethought what I was thinking, and I started with these RAMs up here, and you can see I removed these RAMs, socketed them, and I put them in one at a time, and I found out which circuit was funky. Here, this is the bad chip right here. It's a 153, but I'm going to remove that. And now it goes back. I'm sorry. But you see it's doing the same thing. You watch up here when it crosses. See that? Anyway, what I did was I removed each one of these. I'll remove this guy right here. This was the bad circuit. Ah, dang it. That's the bad circuit though. And now you come over and you look at this. And it looks great. But that is just a red color of that sprite. Right? That sprite basically contains two colors, red and yellow. The other one is what was messed up. This one's fine. But if I put the other one in by itself, and let me do that, I'll show you. Let's remove this without breaking it. Try to anyway. Darn it. Oh, I hate doing that. Anyway, now let's put this one in over here. Okay, I think it's in there, right? I don't know if it's in there or not. I'll be right back. Okay, now I have this RAM in the board, and I was not right. This one is basically all red. This one's kind of a mix of every color. And I don't know exactly what's going on there with that, but anyway, you can see as this crosses up here, see that? As it crosses that flickers, or it goes away. You know, see that? There you go. Now I will take this 153 here and put it over here if I can. This stuff is not easy to do one-handed. Okay, there. Yeah, there we go. Now look, everything is straightened right up. The fireball changes colors based on where it's at. It's not just random like it was before. See that? Now it's blue because it's in the blue area. Now it's pink because it's in the pink area. Now it'll be green. Right? Now it's blue again. It's in the blue area. Green, blue, green, and coming up to pink. Because that is the tiling. This, if you pull those ROMs out, you'll have green square, you'll have pink square over here, you'll have blue square over here, and a big pink square over here, green over here. You know, it'll be quartered into those colors. So this guy's going into those colors and turning those colors. See? The turquoise, pink, down to blue, back up, you know. So that's what's going on. That was what was going on. I know I'm not explaining that very well, but it's just a tiling issue. This was not selecting, this was providing data to this guy. This is the data input to this RAM here. And yeah, somehow it just, that was the problem. So I'm not going to sit here and try to explain it because I don't know exactly how it works, so you know, but it is what it is. That was, you notice you have a problem with a color problem. So I think I did say that I burnt these Proms. I did replace these Prom chips because they were no good. I mean, they were falling apart. Literally, the legs were doing this. They were hanging on by a thread. So I replaced both of these guys. I pulled these and socketed. That just helped me That helped me diagnose the board. Basically, was starting. Let me show you exactly what I was doing. Exactly what I did. If we come over here and you look at this part of the schematic. Okay, let's do this. Right? There's those two RAMs. And they output these signals right here that go to these flip-flops. And I didn't bother with the flip-flop because one of the signals was good. I figured the flip-flop was probably okay. This is the guy, or that mux, wherever that mux went. It's up. Right here. That's the mux that has the problem. It's just the one bit going into that RAM is funky. So, yeah. That's it. Alright. Well, I'm going to go ahead and replace that chip properly. I wish I had a better explanation, but I really don't. I removed these guys and followed the problem back. You know. The RGB outputs go to this Prom, off of this Prom right here. And those are input. The addressing to this guy are the 2 bits from this guy and I believe bits off of muxed bits from these data outs, I believe. I'd have to look at the schematic again, but you follow that back. I followed it back from this Prom and it led me to the signals off of these guys, and that's what I wanted to look at. I was figuring one of the RAMs was going to be bad, but it wasn't. It turns out it wasn't. It was what was feeding these RAMs was bad. This guy. So, goodness gracious, I'm having a hard time explaining things today. It's hard to explain something when you just kind of, it's not really very scientific how I found this. I just started at the end and worked back. That's all I did. You know, you start at the RGB outputs and you work back. And I didn't go this route because I figured that was all good. It was a color problem. So I just decided to start right here with the RAMs. These RAMs. Yeah. So sorry about the babbling. Goodness gracious. Alright, let me replace this guy and I'll be back. Okay, and we have our new 153 in the board next to our new Prom chip. And as you can see, our colors are now correct. There's no funkiness. So we'll set up our camera, do a little play test, and make sure everything's working as it should. All the inputs and sounds and everything like that. So let's do that. I will be right back. Okay. And here we go. I'm gonna try to start a game with all 4 contestants. So here we go. Okay, here's 1, 2, 3, 4. Yep, I got all 4 in. This one kind of moves funny. Maybe not. Maybe it's just, I don't know. No, it's just my pot's goofy. Yeah, that's definitely goofy. I don't think this is my pot. Alright, I'm going to do something. I'm going to do an experiment. I wonder if it's my plug. Okay. Reset. I wonder if the pokey chip is bad. Let me grab a different pokey. I'll be right back. Okay, it's actually not the pokey that I'm worried about. I put another pokey in it anyway, and it did the same thing. So I came over to the schematic, and we have all of the pots come in through an LM339, and pot number 1 is the one that is in question. So I'm going to replace this LM339 at A5, and I think that'll take care of my jittery pot. Okay, so I did replace the LM339 right there. It's an HP part number, but it is an LM339. Turns out that was not my problem though. My problem was my pot was flaky as all get out. This guy right here. So I sprayed in there a little electronic lube, worked it in really good, and I think it fixed it pretty good. So I'm going to set the camera back up and play a game to demonstrate that pot number 1 is just fine. So I'll be back. Okie doke. I'm going to go ahead and I'm just going to play player 1 against the computer. And now we go. Here we go. Goodness gracious. Kill something. Yeah! Whoa! Whoa! Get away! Oh, darn it! That was awesome. That was pretty fun. Yeah, see, it works just fine now. It was my pot. Flaky pot. So, that was pretty cool. Lights back on. Alright. Zoom out. Warlords is complete. I'll let this thing run for a few hours. Make sure it stays good on, make sure it stays on the good. Yeah, so we had to hunt down the bad monks inputting these RAM. Had a bad RAM right here. Had to clean up a lot of stuff was reflowed on the back. I had to clean that up. Resocketed it. New proms. I programmed new proms because the ones in there were junk. They were just falling apart. 339 LM is nice and fresh. It was not the problem, but hey, got a new one in there. And that'll do it. That's about it. I do believe. Alright guys, thanks for watching, and we'll see you on the next Classic Arcade Repair. See you guys.